In this video, we'll discuss how to solve and represent the solution to linear inequalities. So to get started, we want to make sure that we can understand how to solve an inequality with one variable and express those solutions in interval notation. So as a warm-up, let's insert the correct inequality sign between the given numbers. So in this particular case, 4 and 13, 13 is bigger, and remember that when we put our inequality symbol, the bigger part is open to the bigger number. So 4 is less than 13. Notice that if we multiply both sides by -1, we now have -4, which is greater than -13. So always remember that when we multiply or divide by a negative number, we're going to have to switch the direction of the inequality. In addition, we're going to use interval notation to represent our solutions. And I know we've talked about interval notation before, but if you're going to use a less than or a greater than symbol, these two symbols here, we're going to use parentheses. If you're going to use a less than or equal to or a greater than or equal to symbol, you're going to use brackets. And if you use either positive or negative infinity, because we can't really reach infinity, we use parentheses. So here are some examples above. I'll let you read through those, but we're going to do some examples. So for the first example, it says solve each of the following. Represent the solution set with interval notation, set notation, and also graph the solution. I like to actually graph the solution first because it helps me understand the other two solutions. So we're going to start here with 3x minus 5 less than 6 minus 2x. So we essentially treat this like an equation. I'm going to add 2x to each side. That's going to give me 5x minus 5 is less than 6. Then I will add 5 and get 5x is less than 11. And then I'm dividing. Now I'm dividing by a positive number, so I don't have to worry about switching the inequality. Okay, so on the graph, 11/5 is slightly more than 2, and this is a less than symbol. So we're going to have this at 11/5, and we're going to shade to the left. So let me do this in another color just so we can see it. We're going to shade to the left like this. And just a side note, if you always have your x on the left side of your inequality, then the direction of this arrow will tell you which direction to shade. But your x does have to be on the left-hand side. So for this one, if I read the graph from left to right, I know that my inequality symbol is negative infinity up to 11/5 parentheses. The set notation, which we don't use very often, we use x, it's a set, so we have the set notation, x, we read the bar such that, and then we just repeat the inequality, x is less than 11/5. Let's do that again for this next example. 13 minus 7x is greater than or equal to, that equal to tells me I'm going to have some brackets, 10x minus 4. So I like to have my x on the left, so I'm going to subtract 10x from each side. So we're going to have negative 17x plus 13 is greater than or equal to negative 4. We will then subtract 13. So negative 17x is greater than or equal to negative 17. And then we're going to divide by a negative 17. So this inequality symbol, and I typically do circle it, is going to have to switch direction. So we're going to get x is less than or equal to 1. So on our number line, here's 1. Less than or equal to would be a bracket and shaded left. Because I kept my x on the left-hand side, I know which way to shade it. And my my interval notation is negative infinity, parentheses, up to 1, bracket. My set notation would be x such that, and then just repeating our inequality, x is less than or equal to 1. Okay, let's take a look at a couple of others. This one has a little bit more multiplication involved. So we're going to take this one and distribute. So if I distribute my 4x, I end up with 4x squared minus 8x is greater than 2, and then I'm going to FOIL these two. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 1x. And plus 3. The next step would be to distribute this 2 through all 4 of those. And we're going to have 4x squared minus 8x is greater than 4x squared minus 12x minus 2x plus 6. I could have, by the way, combined these before, but I didn't. So now I'm going to do that, and I'm also going to subtract 4x squared from each side. So I have negative 8x is greater than negative 14x plus 6. And then adding 14x to each side, 14 minus 8 is 6, so 6x is greater than 6, x is greater than 1. So we've got 0, 1. It does not have the equal to, so we're going to use a parenthesis, and it's greater, so there's the graph. Reading the graph from left to right, we're going to have 1 up to infinity, and set builder would be x such that x is greater than 1. Okay. Let's review this interval notation and the idea of domain. So when we look at a function, there are 3 things that cause problems or things that we have to exclude from the domain. One is if we have division by 0, and one of the others is a square root of a negative, which will apply here. And the third one, which we have not had to deal with yet, is a logarithm of a negative. So in this particular case, we know that 1 minus 5x has to be a positive number or 0. So we're going to say greater than or equal to 0. I'm going to subtract 1 from each side, and I will get, after I divide by a negative 5, I'm dividing by a negative, remember what to do, less than or equal to 1/5. So the graph for this would look like a bracket shaded to the left. Our interval notation would be negative infinity up to 1/5 bracket. And our set builder would be all x values such that x is less than or equal to 1/5. So there's kind of an application of why we need to be able to solve these inequalities. All right, let's take a look at something called a compound inequality. A compound inequality is when you join two or more inequalities with an and statement or an or statement. So when we're talking about an and statement, we're looking for an intersection or an overlap, which is represented by the upside down U. And if we're talking about an or statement, we want the union of all the solution sets, which is an up U. So for an example, if I say minus 3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 7, we want to know where these two inequalities intersect. We can also write this one as, because these are the same, 2x plus 5 has to be less than or equal to 7 and greater than negative 3. We call this a chain of inequalities. So we're going to do something with this particular inequality below, and we're going to take a look at this statement, which is an and statement, so we're going to be looking for the intersection, and this statement, which is an or statement, and we're going to look for the union of these. And we're going to graph it, give the answer in set builder and interval notation. So when I work with this chain of inequalities, I do the same thing that I would do if it was an equation, only there's 3 parts here. So I want to get my x by itself. I'm going to subtract 5 from each piece. So I have negative 8 is less than 2x is less than or equal to 2. And then I will divide everything by 2 to get that x by itself. Negative 4 is less than x and less than or equal to 1. Now the nice thing about using this chain of inequalities is graphing this, we can see that what we're saying is x has to be between negative 4 and 1, not including the 4, but including the 1, and then shade in between. That also helps us with our interval notation. It's just negative 4 up to 1, bracket. And our set builder would be x such that negative 4 is less than x is less than or equal to 1. This is usually how we represent our solutions as an interval. All right, let's take a look at the next one. This one is an or statement. So again, I'm not looking for the intersection here. I'm looking for the union of the two sets. So I'm going to add 5. I was ahead of myself. 2x is less than or equal to negative 2. And dividing by 2, x is less than or equal to negative 1. Or, for this part, I'm going to add 5 and get 2x is greater than 12, or x is greater than 6. All right, when we look at our number line here, we want to be less than or equal to negative 1, so this direction, and it's equal to, so I'm using a bracket, and greater than 6, so this direction. And our interval notation will be negative infinity up to negative 1, union, parentheses 6 to infinity. Our set builder notation, x such that x is less than or equal to negative 1 or x is greater than 6. So really what I want you to pay attention to is these two words, and or. These really tell us whether or not we're looking for the intersection for and or the union of the two sets for the or. That's the most important part about this. Okay, lastly, let's look at an application problem. So for her house painting job, Erica can be paid in one of 2 ways. Plan A pays $250 plus $10 per hour, and plan B is $20 per hour. And the question is, for what values of N is plan B better for Erica? And we're going to use N for the number of hours. So we've already got this, N equals the number of hours, but I'm going to write it down anyway. And let's take a look at plan A and plan B and represent those algebraically. So plan A is $250 plus $10 for every hour, so 10 times N. And plan B is just going to be $20 times N. We want to know, when is plan B better? In other words, when is 20N greater than 250 plus 10N? So we're going to subtract 10N, get 10N is greater than 250, and dividing by 10, N is greater than 25. So we can say plan B is better for Erica after 25 hours. That concludes this video. Thank you.